Sorry, good start. Welcome to the third part in cognitive psychology, week 2, perception lecture, and our third part is on Gestalt theory. Okay, so before we start with Gestalt theory, I would like you to do a little exercise which you can do at home. We now already have had an introduction into perception, and we have seen some examples in psychophysics, and I would like you to think of whether you can think of further everyday examples where knowledge of perception might be relevant and useful to you. And I want to just provide one further example, and which shows you on which level this might become relevant. And this is for the development of fonts. So a font, you know how the letters are exactly shaped on the screen. You know, Times New Roman, Arial, and all these Calibri. And this is called typography. And I will give you two examples of that. So this one here means Chris Brown's hits, or some people may read Chris Brown, and then I won't speak that fully. Or this one, I think the store is called Megaflix, but you may read this letter slightly different as well. And so if you do that, so you develop fonts, you have these type of writings, you should be aware of certain rules and laws, which we will see in this part actually. So pause the video for a moment and try to think of other things which might be relevant, where this might be relevant. Okay, so let's continue and do this part on Gestalt theory. Okay, Gestalt theory. Gestalt psychology. So Gestalt theory was proposed roughly 100 years ago by a stream within psychology which is called Gestalt psychology. It emerged in the early 20th century, mainly in Germany, and it used a different scientific approach. The most common approach, in particular nowadays, it's called reductionism. And the idea is, if you have a complex phenomenon in psychology or physics or chemistry, and you can break it down, try to break it down first, and then investigate the smallest possible parts to understand them. So you just try to break it down and understand that. Gestalt psychology tried to take a different approach, and they termed it the principle of totality. So one should investigate the whole percept in this example, taking into account all possible parts and not break it down and see, okay, how is a line perceived? And they say, that doesn't matter really, I need to see the whole percept. How is a letter, how is a word perceived? And things like that. We have a lot of examples getting around to that. And I'm fully aware, this is roughly 100 years ago, that this approach is not really an either or to the reductionism. It just complements it, and it actually makes more sense for some areas, and in some areas it doesn't make too much sense, and you should just look at the parts, and it's totally fine to do that, of course. If you wonder where the term Gestalt psychology comes from, Gestalt is a German word, and it basically means the essence or shape of an entity's complete form. The things we will see in a moment, which have been proposed by Gestalt psychology, they provide a really good description of some perceptual principles, how we see things, how we group things together to perceptions. But it doesn't explain why it's happening that way. So we should be aware of that. It's more descriptive than that. And one underlying principle of the whole thing, which of these mechanisms of Gestalt psychology, is the principle of Prägnanz, which again is a German word. And it means something like simplicity, pithiness, or conciseness. So the idea is that when we interpret and perceive our sensory input, that we try to interpret it in a way which gives rise to the most simple or most stable, most regular, orderly and or symmetric percept. So if you have an interpretation which would give rise to a rather complicated form, then this would be ignored for the idea of something simpler. And we will see examples of that in a moment. What the main thing which is remembered today in perception, which comes out of Gestalt theory, are the laws or principles of grouping. So how do we group items together in our visual field? And there are quite a few of them, and we will discuss a couple of the main ones to just give you an idea. And if you're interested in more, just search it in the internet and you will find all of them. So the first one I would like to introduce is the law of proximity. And that's very easy and straightforward. Objects which are close together spatially form a group. Let's have this look. Most likely you will on the first side at the screen see three groups. These, and these. If you look closer, you can see that although on the first sight when we observe everything, this may come up as a group, when we look closer and focus on that bit, you will see, okay, that groups up here as well into two groups. So objects which are close together form a group. And this can even be on a hierarchical level of groups and subgroups. The second law is the law of similarity. And it states that visual elements which are similar to each other form a group. These are examples. Here we have similarity in color, and automatically the white group together, the black group together, or here we have this like yellow half circle against a red background. It may look like this. We may also have similarity in shape, for instance. So we automatically group together this into columns of squares and circles. So similar visual elements form a group. That's the law of similarity. Then we have the law of closure. And this says that objects are perceived as a whole even if they are not complete. So examples. Here we don't see separate elements of a circle, but we perceive this as a circle. Some bits are missing, obviously we see that, but we perceive it as a circle or as a square here. If you look at the logo of the WWF, you will see that it also plays with this effect of closure. There's actually no line here, but we automatically close the shape here to see the shape of the head, the form of the head. Other examples is the logo of IBM, or if you remember our first lecture, where we had the introduction, we said, how is it possible that we can read that, although something is missing here? And one interpretation or explanation is the law of closure. If the element is not complete, we can still complete it. And this has helped in this case, when you remember the first part, the introduction, that we have the top-down information, top-down effects, which tell us how the letter E looks like to complement and complete that. Another law is the law of symmetry. And this states that objects which are symmetrical around a center point form a group. And that's very easy to demonstrate. You see here, these automatically form groups, although they are all roughly equally spaced. You don't group these two together. That one's an interesting one. Most people still would group these parentheses as one group, the square brackets as another group, and the curly brackets as a third group, because of the law of symmetry. However, if you look closely, the law of proximity would tell us to see that as a group and that as a group. So it shows that at any point in time, it might actually be that more than one law is at work, so to say, and that one may override the other one. Which one overrides which is really dependent on the exact visual scenery, on the exact percept, what we are seeing. So if we put these brackets too far apart, at some point the symmetry law may break down and we may group them together by the law of proximity instead. Okay, the law of continuity says that we tend to perceive objects as forming smooth, continuous patterns. And this one is one where we can particularly nicely illustrate this principle of pregnance, that we prefer easy interpretations instead of complicated ones. So take this percept here. Most people will perceive two lines here. One line running from top to bottom, the other one from left to right. However, as illustrated by the color code here. However, from a pure neutral observer point of view, let's say you are a computer, you want to program a computer for vision, it could be that as well. This is one line, this is the other one. From an objective point of view, these two interpretations are equally likely and have the equal value. However, humans strongly prefer this one because of the law of continuity. We prefer something continues rather smoothly as doing, like in this example, sharp turns. Another example is when we see these two things, we usually see a cross and an overlaid triangle. So this is our typical interpretation. Again, when you think in computer vision or something, you could also see it as three objects which are shaped like this. So one object shaped like this complicated shape, and the other one attaches here from the bottom. However, the law of pregnance says this is more simple, so prefer this one. And the law of continuity, because these are, here we have much more continuous lines, and here we have much more corners which we have to cut to see that. Where the law of continuity holds as well is like here, where we see two lines which are covered by a square. And if you look closely, you see that something is slightly wrong here. And this is that actually doesn't work. So technically, if there are straight lines, it can't be the same lines. But our percept is still that it's one line which is just covered up by the object, because we have this law of continuity. And the final one I would like to introduce is the law of figureground segregation. And this tells you that when we have a visual field which we look at, or an image, we tend to structure it into two parts, a figure or foreground and a ground or background. And what's coming now, you know with all that. This is, for example, the Rubin illusion, where you can see two faces with like the forehead here and the nose and the lips. So this is one face, this is another face, they look at each other. And when you see them, they constitute the foreground, the figure, and the blue will just be the background, the ground. Or it flips and you see this cup, with the base where it stands on, and here you can fill in water or wine or whatever, and here's the handle to hold it. When you see it that way, then you will see the cup in the foreground and the faces in the background. And these are called bistable percepts. You can perceive them in two different ways. However, it's impossible to see both at the same time. They will flip back and forwards. And with brain imaging studies, it has been shown that the neural correlates switch accordingly between the perception of a face and the perception of the cup, depending on what you see. So there's very good reflection of that. Other examples are, for instance, this painting by Escher, Sky and Water, where in particular in the middle area you either see the fish and then the ducks are the background, or you see the ducks and then the fish become the background. So this nicely illustrates this as well, where we have this bistable percepts. Another example is the scenic state route sign from Idaho. Shield is the wrong word. Sign, that's from German. To literal translation, where it's a little bit like you have a person looking into that direction with the nose here and the chin and here the forehead, which a lot of people see here in that. But actually, I think the white one probably is how the state of Idaho looks like. Okay, so when we go back to our example in the beginning, where quite a few people may misread that. What went wrong in this example? Now, knowing the Gestalt laws of grouping, we can explain that. And there are actually two explanations for why we may read the letter U here. It's supposed to be an L and an I. However, they are very close together. So maybe they are too close together. So the law of proximity groups them together as one letter. Alternatively, or maybe at the same time, the law of closure may work, and our perceptual system may interpret that as the letter U, which is just broken up a little bit. So it completes that. Let's have a look at the other example. The creators of this website probably intended a grouping by law of similarity, because if you look, there are no spaces in here, so we need some clues how to group. Usually when we have text, you have a space between words. They didn't do it here. They thought, okay, let's do it by similarity, and it's the boldness. Chris is bold, Brown's is non-bold, and Hit's is bold again. Now, there might be a competing law at work, and this is the law by proximity. The problem is this high comma here. This results in the space between the N and the S. So for some people, the S may be bound to the Hits, forming the word sh, it's, and Brown on the other side. So, and this may then depend on how big you see the reading on your screen. It may depend on your own perceptual system. It may be how strong you are looking at this. Maybe the people who programmed that were so used to interpret it that way that they are kind of trained to use that law. But it shows you that not all people do it that way, and there's a problem if you do it the other way. Okay, so to summarize Gestalt theory, it describes the organizing principles that guide perceptual processes, at least some of them. It's these laws of grouping, similarities, and it's quite relevant for design of things. And to illustrate that, let's have a quick video clip. Wrong image. Let me put that. So in this video clip, they actually speak about one or two additional laws which we haven't talked about. And this just illustrates you that these laws are actually used in product design, in web design, in real life. It's not a theoretical stuff you just have to learn and never use again.
Such as this Rubin vase. The Gestalt laws can be used to describe how we perceive much of the structure and meaning in digital interfaces. Looking at this web page, we can find examples of each law. These tabs and this checkout information form two distinct groups because of the law of proximity. These tabs and the navigational system strengthen our perception of groups because they have similar characteristics. We perceive this rectangle for the coupon as a whole rectangle, even though it is clearly obstructed and we cannot see all of it. The use of the dashed stroke in the product grid relies on the law of continuity for us to perceive this as a solid line, and our eyes follow along that dotted path. And when we choose to add an item to the cart, we receive feedback in the form of a mini cart, and it slides down as a drawer, and we perceive that as a group because all of those pieces of information move together, the law of common fate. Remember, the Gestalt laws describe how and why we perceive the world as filled with whole, distinct objects. They're not rules for how to design. When we encounter devices or interfaces that are vague, ambiguous, and difficult to understand, we can use the Gestalt laws to help us identify the source of the confusion, then develop ways to improve the design and ensure that people are perceiving the device or interface in a clear and understandable way.
Okay. So, as already voiced in this video clip, there is some criticism to the Gestalt theory. While there is a really nice description of some key principles, there is no explanation why these principles would exist, or why or how they have developed, evolutionary or things like that. It doesn't provide a model of perceptual processing which would allow us to, for instance, predict new effects and things like that. There's also no reference to depth perception, which is why we speak about this in the next part. And yes, so are there any questions to this? If so, as usual, please PY5701, PY2701 discussion forums, and I'll look on them daily and answer your questions or bring them to the seminars. Thanks a lot for watching and listening, and see you hopefully for the next part soon.